Hi everyone, and welcome back to Dr. Brown Codes. I'm your host Nick Brown, and today I'm going to be going over an intro to R in the Tidyverse. So this is really going to be a great beginning tutorial for those who are brand new to coding in R and want to know how to get started. So here I am in Posit Cloud, and this is where I'm going to be doing all of the work today. You can also code along with me in Posit Cloud. I will link to a video that shows you how to get set up with Posit Cloud and how to link to the GitHub content that has the code that we'll be working on today. So here I'm in Posit Cloud. I'm going to go to my space that has my code in it. And then here in the content is something that I call Dr. Brown Codes here. And if we open this up, we can see that this now gets us into all of the different folders for Dr. Brown Codes. Today we're going to go over number 4, Intro to R in the Tidyverse. So here we can see that there's only one file in this folder. If we click this to open it up, this is going to open up the Quarto document. Quarto document is really just a way to run code. And you can see that it's telling us right now that it needs some packages installed. We can click right here and install this, and so we can get that done. That'll probably take a minute or two, so we'll pause here for a second while that gets loaded. All right, great. So we just installed all those packages we need. We can X out of this. And now we are looking here at this Quarto document. So a Quarto document is really, as I talked about, just a way that you can include code in what are known as chunks. And you can see here this first chunk of code starts at line 7. It has these 3 backticks. It has R, that's telling you that it's a code chunk. And it ends on line 13 here with these other 3 backticks. So everything in the middle here is a code chunk. If we hit this play button over here, it will run this code chunk and run all of the code that is in there. We're not going to do that because that just installs the packages we just needed, and we just did that in a different way. But for some reason, if you haven't loaded the packages, installed them, you can do it here. We can then scroll down a little bit, and we can see here at line 15 through 20 is another chunk of code. And this chunk of code we're going to run because what it does here is it actually loads those 2 packages. And the first package is the Tidyverse. This is a whole collection of really cool packages for R that make coding even easier for everybody. And then the next package we're going to load is what's called immunogenetr. This is an HLA-specific package that I co-developed with a student at Penn. And we're going to be using this today as we find things to do in R. So we can run this code chunk here with this little button. And you can see it's giving us some information down here that it's loaded these packages. Another nice shortcut, if we want to load a chunk, if we have our cursor in that chunk, we can do Control-Shift-Enter, and that will also run that line of code. All right, great. So the next thing we're going to do is we're going to start coding. And when we think about coding in R, we think about functions. And really what we're doing with coding is we're finding the functions that we need and we're stringing them together in a way that makes sense and does the things we want to. The very first function that we're going to try is print. And so here, if we can look down here at lines 28 through 30, we have this chunk of code here. We can either hit play or we can do Control-Shift-Enter. And we can see that we've set up this function with an argument inside of it, an argument or parameter. This is really the setting of the function. And we can see here that we have print, and the setting we put in there is HLA dictionary. And so that is the thing that we want to print out. All right, so we've already run our first line of code, and we can see that what happened at the bottom here is we get a snapshot, a view of the HLA dictionary, which is a table that's called a tibble. And essentially this is just a type of data structure that looks very similar to an Excel spreadsheet or any other spreadsheet that you might have used before. And so using RStudio here, it gives you a very nice way of going through the data. We can see that this particular tibble, it's telling us that there's 100 rows and there's 3 columns. We can clearly see here the columns are IPD accession, HLA allele, and WHO assigned type. And we can see that this was the HLA dictionary table, and it makes sense that this is what we're seeing in here. We can see down here that we can even scroll through the 100 different rows, doing this, and we can actually go through and see. We can make things bigger if we want by clicking this button over here, and then we can see a lot more rows at a time. All right, so we've used our very first function in R, print. And one of the things I want to point out is if you're ever unsure how a function works, you can always go down here to what's called the console. You can hit question mark and then the name. Oops, I had the caps lock on. Let's try that again. The name of the function, and you can see print comes right up there. And when we do that over here now in this help file, it will show us all the information that we need to know about that function. And for us, the most important here is the usage, and it says print X and then lots of other things in there. And essentially what that's telling us is you need to have the thing that you want to print. And print here just means show on the screen. And then there's lots of other things that you can put in there, but the main thing is there that you have to tell it what you want. And that's exactly what we did. We set up our print function with the thing that we wanted shown on the screen. All right, great. Let's move on a little bit. And I'll just say that I'm not going to go through all of the text that I have written here. This is really if you want to follow along, but you should be able to read everything that I've been doing and do the same thing. All right, so now line 33, it's saying it's our turn to write some code in the chunk below. Use the print function to take a look at a tibble called HLA typing 1. All right, so if you want to pause here and and do that yourself, that would be great. Otherwise, let's see, we want to print. So if I just start typing print, you can see that this print pops up. I can hit enter there. It already gives the parentheses for me. And we want what's called HLA typing 1. So I'm just going to copy that, paste it into here. And if we run that, we can see here is another tibble. This has 10 rows and 19 columns. We can use this little arrow to kind of scroll through and see all the different columns there. This looks pretty clear that this is some genotype at the A, C, B, DRB345, DRB1, DQA1, DQB1, DPA1, and DPB1 loci. So this looks like, HLA typing 1. This looks like it's a genotype of 10 different individuals there. Great. So you just wrote your first line of code. Let's move on now here. The next thing I want to introduce is a function called the pipe. And the pipe looks a little funky. It's this thing here. It's a %sign, a right arrow, and another %sign. But the really cool thing about the pipe is it allows you to set up your code to look a little bit more like actual English text, like a sentence almost. And the way this works is you think about the pipe as then. And so what I'm showing down here at line 49 is this exactly the same line of code we had up here. We can see up here we had print, and inside of those parentheses we put HLA typing 1. With this pipe, what we can do is we can take HLA typing 1 and then, right, remember that we tend to think of this pipe, we read it as then, we can pass it to the print function. So this makes it much easier because we can look at our code and say, all right, we're going to take the HLA typing 1 and then we're going to print it. And if we do that, we should see exactly the same thing that we had up there. Really, this line of code here is identical functionally to this line of code here. All right, but why are we making it a little bit more complicated? And the reason is because we can string these things together in sentences that really make a lot of sense to us. All right, let's take an example down here at line 56. Let's just read this without even knowing anything about it. All right, HLA typing 1, then we're going to pass that to a function called select. And we don't know anything about the select function yet. But we can see here inside that select function, we have a couple of parameters set up. One is a patient, and the other is A1. And then we are going to print that. All right, so we're not really sure what's going to happen here, but we maybe have some ideas just looking at the code, what might happen. Why don't we run this and see what happens? All right, so we took a table up here that had all these different columns in it, and we end up with a table down here that only has 2 columns in it. If we go back and look at our lines of code here, we can see that this select, we said select the patient column, and select the A1 column, right? So we can clearly see here now that this select function is a way to subset a table, right? If we take a table that has many rows in it, we can say which specific columns we want out of it. I'm sorry, if we have to take a table with lots of columns, the select function subsets on individual columns based on the names that we put in there. All right, this is great. This is a line of code that has two different functions in it, and we're stringing these functions together really in a nice pipeline that's doing something more functional with our data. All right, so the select function. The select function is really the first of the main functions of R that I want to introduce here. Since oftentimes in R, in the Tidyverse specifically, which is a different way of, a different dialect of R, if you will, the data that we have are often in tibbles like this, these kind of tables. And select is really useful because it's a way that you can shape and change your data in these tables in ways that are going to be more useful for you. All right, the next thing I want to note is that we had this nice code sentence here, right? Take table typing 1, then select column patient and column A1, and then print it, show it on the screen. But another really cool thing that you can do with R is you can put each one of these lines of code on a different, each one of these different functions on a different line of code. And you can see here that now it's almost looking more like one line of code at a time is doing something very specific, and it makes it easier to read. So here we can see it's the exact same thing. Take the table HLA typing 1, then select these two columns, then print it. So if we do here, Control-Shift-Enter to run that chunk of code, you can see it gives us exactly the same output. But the nice thing here is it just makes it easier to read. We can see one thing is happening on every single line of code. And it just is a nice way to get R working and make it more readily easy for us to use. All right, so let's play around with the select function a bit more. All right, so here in line 72 or 74 here, we have an incomplete line of code. Let's set it up to keep the patient columns and all HLA A, B, and C columns. And there's a hint here. You can separate each column you want with a comma, or you can use this colon sign to take all the columns between the two selected columns. All right, so let's see where it's asking us to keep the patient columns and all HLA A, B, and C columns. All right, so we can go back up here and look at all the columns. So it says that we want the patient column. So what I'm going to do there is I'm just going to double click on it to highlight it, copy it, go back down here to what we want. I'm going to put patient in there. I'm going to put a comma because now I want a different set of columns that we want to do, and it's saying to take all the HLA A, B, and C columns. All right, so we're going to have to go back up and look at this. All right, so A1 is the first A column there. So what I can do there is I can put A1 in there, and I can use this colon to say every column between A1 and B2 is the last one, right? By using that colon, it's saying basically take all of these that are between these two. All right, so let's try that all the way down here. I'm going to copy that into there. And if I do that, sure enough, so now we have a nice table that has the patient and it has these 6 other columns. Perfect, so that's what we wanted. Let's see down here, the solution code, select patient to B1 would work. Also, we could have used this line of code where every single individual column we could have put in there. One of the really cool things about R and about most coding languages you'll find is that there are oftentimes many different ways to do the same thing. And it gives you flexibility in the way you want to do it. And it also, you'll find as you do things that there are more efficient ways to do it. But sometimes it's not always efficiency is the best. Sometimes spelling everything out will make the code a little bit easier to do. All right, so let's move on a little bit here. Now that we've learned about the select function, let's move on to another very useful function, filter. All right, so the big difference here, while select subsets a table by columns, filter subsets a table by rows. So let's take a look at the code below and see if we can figure out what it's going to do. All right, so we have a nice a line of code here, HLA typing 1, then filter A1 equal A asterisk 01 colon 01, then print. All right, what do we think is going to happen here? Well, we can run this to take a look. All right, so we took that HLA typing 1, which if you remember, if we go well up here, you can see it had 10 different rows down there. And now we have a table that only has 2 rows. And if we take a look at this filter function, we can see A1, and it looks like it's actually filtering on the column A1, and it was trying to do everything that had A asterisk 0101 in there. And we can clearly see here that these 2 columns have that in there. One interesting thing you might notice is that there's these 2 equal signs in there, and that might seem kind of weird. And the reason for that is I have written down here, it's because how R handles what are known as relational operators. And equal is the equality operator. Really interestingly, exclamation point equals is the inequality operator. Let's see what would happen if we, instead of using equal, we used exclamation point equal. All right, so what did we get there? We had 10 rows to begin with, now we're down to 8 rows, and we can see that none of the columns, none of the fields in A1 are A0101, right? It's removed everything. So another way to think of this is saying we're telling it to filter for any row of A1 that does not equal A0101. And sure enough, that's what happened. And so we can see here now we're getting cool logic operators in here, and we're really being able to work with our data a little bit more. All right, very cool. Let's try something here. So it's saying the filter function is really useful. Let's try writing a full line of code using the functions we've learned so far. All right, great. So in this code chunk here, it's giving us a prompt of what to do. Write a line of code that will take the HLA typing 1 tibble. All right, so let's just do that. HLA typing 1, we can just copy that down here. Filter for C0718. All right, so we need to get that pipe in there. A really nice way of doing this, you can do Control-Shift-M, and that will automatically give you your pipe. I'll hit enter to get a new line of code, and it says filter for C0718 in the C1 column. All right, so that means I need a filter function here. I type filter, it already pops up. I hit enter, I get the parentheses there, and it's saying in the C1 column, so oops, I don't need to copy that. I don't need to cut that, I can just copy it here. Filter C1 space equals. I'm going to put quotes in there, and then we want C0718. So Control C for copy, Control V for paste, and then select for columns. Oh, it's having us do even something more here. So I can do Control-Shift-M to get my pipe in there, enter for a new line, and then it wants us to select. Look at that, I can just type SEL, enter, and now select for the columns. All right, I can just take all of these, copy it down here, copy there. I need to take a look at things, patient, comma, C1, comma, C2, comma. Oh, this needs a comma here, and then delete that. All right, so that looks like it's set up well. Those are the 5 different columns it wants me to do, and then print the result. All right, so Control-Shift-M for one more pipe there, and then print. All right, let's see if that is a functional line of code. I'm going to run this here, and sure enough, we can see that we have filtered for the 2 rows that have C0718 in there, and then we just selected the C columns and the DRB1 columns. Perfect. We should see down here, that looks very similar to what the solution was down there. All right, great. So we've learned quite a bit so far, but I want to get to the last really cool function, and that is the mutate function. It's got a cool name to it, and what it does is even cooler. All right, so the function, the mutate function, makes a new column or changes the data in an existing column. Let's play around a little bit and see how this works. All right, so we have this these lines of code down here. And we know a little bit about how these functions work now. Let's see if we can read through and figure out what's going to happen. All right, so this says take the HLA typing 1 table, then select these two columns, the patient column, the A1 column. All right, fair enough. Then mutate A1 underscore new equals A1. All right, so this is the new function here. And what this is telling us is that we have these two parameters in here. And the first parameter is what are we going to call our new column? And the new column, we're going to call it A1 new. And the equal means what data are we going to assign to that column? And the data we're going to assign is A1. So basically we're taking data from the A1 column and we're going to assign it to this A new column. And then we're going to print that so we can see what the output looks like. All right, let's run this and see what happens. All right, so now we have this new column, A1 new, and we can see the data here is identical to the data that's in A1. And this is because, as I talked about, we have taken the data that was already in A1 and we have assigned it to this new column there. All right, cool. We use this new function, mutate, we made a new column with it. So I will say that mutate is an incredibly useful function because it can change your data in really specific ways, even by using other functions inside of the mutate function. Functions inside of functions, it's like Inception. All right, I wrote myself a cool joke there. I just had to read it out. All right, let's play with some new functions that is going to be really useful when we're actually working with HLA data. All right, so we're going to try a function from the immunogenetr package called HLA truncate. Let's run the code below and see what happens and then see if we can do something different. All right, so we have this HLA truncate function, and inside of this function we have an HLA allele at 4 fields, HLA A02, 01, 03, 14. What do we think is going to happen? All right, so we ran HLA truncate there, and you can see this is the output, HLA 0201. So looking at this, it looks like what happened is it took this field, this allele that was in 4 fields, and it truncated it to 2 fields. So the next thing here, it says, see if you can truncate the allele to 1 field. Well, I wonder if there's a way to do that. How would we know how a function works? Well, just as a reminder, we can always just type the question mark down into the console here, and then we can type HLA truncate. There's the function we're looking for. Hit enter a couple times here, and here it's giving us the help file there. It's giving us a nice description of what this function does, and then down here it's the usage. All right, so this function seems to have a lot more parameters to it, a lot more settings that we can use. The very first one is the data, basically what is it operating on. And here that was this, right? The data that was operating on was this allele here. All right, the next thing is fields. And you can see here in the function fields equals 2, that means it has a hard-coded parameter of 2. If you don't tell it anything else, it is going to truncate down to 2 fields. But we can change this, so why don't we do that here? So now here you can see that we have to put this comma after data. So what we're going to do is we have the allele we want to truncate. We're going to do comma space just to make it a little prettier, and then we're going to do fields, and you can see it automatically comes up. I can hit enter, and the fields we want to do is 1. Let's see what happens if we do that. And sure enough, we've got down to 2 fields. In fact, I wonder even if we do 3. Look at that. It truncates it down to 3 fields. So hopefully this HLA truncate function is pretty straightforward. It does what it seems like it should be doing. There's a couple of more parameters in here, but I'm not going to get into them right now. All right, really cool. So the solution here looks very similar to what we just did. If we do the fields equals 1, we're going to truncate down to the first field. All right, so getting back to mutate. We were talking about how mutate is a really cool function that will make a new column or change data within a column. And we can use other functions inside of that mutate function. So for example here, we have this really cool line of code. All right, so let's take the HLA typing 1, and then mutate, we're going to make A1, and then we're going to operate inside of that, we're going to fill it with data from HLA truncate, and we're going to truncate A1 down to 1 field, and then we're going to print it. So let's see what happens there. All right, if we do that, now we can see that we had all of these columns that had 2 field alleles in each one of them. But now we have A1 that has only 1 field there. And we can see why that happens because we set up our mutate function and we said an A1, which already existed, right? So we're not making a new column here. We're changing the data that was already in the column. And we're saying truncate that with the data that was already inside of A1 down to 1 field. And so this is really cool. We can see that we were able to truncate this specific column with all these different HLA alleles in it down to 1 field there. And of course, we could do this with anything else, right? We could do this for A2, for example. Let's just see how that would work. Copy A2, A2, copy, Control-Shift-Enter. If I do that, now we can clearly see that A2 is the one that's been truncated down to 1 field. So this is really cool. We're using a function with inside of another function to do something that's really useful for HLA data. All right, so mutate can be really useful to change data within a column like we just did. But I will say be careful. Sometimes it's better to make new columns with the new data. And how would we do something like that? Let's say here, and we could go back to this line of code, mutate A2, and let's call it something brand new. A2 truncated, let's say. If we do that, Control-Shift-Enter, and now we can see here we have A2, which has the 2 field there. And if we scroll all the way to the end, we can see A2 truncated down here, and now it has that truncated data. So this is another decision you can make when you're writing code about how much data you want to keep, what data you're comfortable making changes to and you don't need to revert to later on, etc., etc. That's one of the things about coding, that you have lots of decisions to make, and sometimes you really need to think through these things when you're doing them. All right, so we've learned really the 3 basic functions of the Tidyverse. Select subsets tibbles by columns, filter subsets tibbles by rows, and mutates creates new columns of data. Let's end this video here with some practice. I'm going to have several prompts below, and we're going to write code as described in each of the prompts. This would be a great time to pause and to see if you can follow along. I have down here all of the solutions to this, but it'd be a good time to pause, and then you come back and you can see how I'm going to work through these. All right, let's do that. First prompt, prompt 1. Write code to simplify the HLA typing LIS table. So I'm just going to start. Oops, I don't need to cut it. I'm going to start by copying this, pasting it down there. Simplify the HLA typing LIS table to keep only the patient, this column, and that column. All right, so we want to subset by columns. I know that first I have to get a pipe in there, Control-Shift-M. And then I am going to use the select function. And we want to keep the patient, comma, the MB1CD.recipient, comma, and the M2 recipient, comma, columns. Now, what's going to happen if I run this? There we go. Look, it's showing us everything. And we could also, of course, tell it explicitly to show us what's happening. It's going to look exactly the same. But there we have it. We have taken this and we have selected 3 different columns there, and it's looking good. All right, great. Let's move on to the next prompt here. All right, prompt number 2. Take the code from prompt 1 and revise it to keep only rows where MB1CD recipient contains allele A1. All right, so it says to take this code. So what I'm just going to do is select all this, copy it, put it down here, and now it's saying revise this code to keep only rows where MB1CD recipient contains allele A1. All right, so what I can do here is at the end of this line of code, I can hit enter again, and now rows, it's asking me to subset by rows, so I know that is the filter function. So filter, and then it's saying the MB1CD, so I can copy that. I can paste that there. I can do equals equals, because that's the identity operator, or the, identity operator, I think that's what it's called. And then contains allele 0801, and so I can copy all of this here. Control C, Control V, filter MB1CD recipient equals 0801. If I do that, oh, I missed something here. Now I need to put in Control Shift Enter another pipe here, because what happened there is it thought that filter was just kind of smushed right into print, but we needed to put a pipe there to say then, right? We can always go back and read our line of code, take HLA typing LIS, then select these columns, then filter for these rows, then print it all out. All right, so if we do that, all right, perfect. We can see here. And there was a question here. How many rows did you end up with? We ended up with 2 rows, because apparently there's only 2 rows in this table that had 0801 for the MB1CD.recipient column. All right, great. Let's move on to the next prompt here. All right. Take the HLA dictionary table and create a new column that will truncate the data from HLA.allele column to 2 fields. Reminder, HLA truncate will be useful. All right. So what I'm going to do here is this is a little trick I can show you guys. All right, so Control Shift M will get the pipe, and the next line of code, I'm just going to say print. And we can do that, and all this is showing us what does this table look like before we do anything to it. And the table here has 100 different rows, and you can see it has 3 different columns. Now it's saying, all right, take this table and create a new column that will truncate the data from the HLA allele column to 2 fields. All right, so I can go back up here, I can hit enter, and it's asking me to change a column. And so I know that's going to be the mutate function. All right, and it's telling me to do it on the HLA.allele, so I can copy that, put it in there. I can hit 1 enter. One of the things I might not have mentioned before, in mutate you only use 1 equals sign, because 1 equals sign is a way to assign something. 2 equals sign is a logical operator. All right, and it says mutate HLA allele equals, and now we want to use this HLA truncate function. All right, so I'm going to put HLA truncate in there. I'm going to have to put another set of parentheses in there. And the stuff that we actually want to, the data that we want to truncate is also in this HLA allele column there. So I'm going to put that in there, and it says truncate it to 2 fields. All right, so I can say comma fields equals 2, and then I have to make sure I do Control Shift M, because I'm passing all of this on to the print function now. All right, so let's just make sure that this looks right to us. We're taking the HLA dictionary, then we're mutating this column with HLA truncate, and the data we're going to use on that is the same column, and we're going to truncate it down to 2 fields. Then we're going to pass it on to print. All right, that looks good. Let's see what happens. Sure enough, so we had here what was many different fields. Some were 2 fields, some were up to 4 fields, and now we got everything down to 2 fields there. All right, that looks great. That was a particularly difficult, complicated line of code, but hopefully following along you can see why we had to do each thing. All right, prompt number 4. Take the code from above. All right, so let's copy this code from above here. Copy, paste. And after you have truncated the alleles to 2 fields, format the alleles in compliant WHO nomenclature with HLA at the beginning. All right, so what we're getting for here is you can see that these alleles here just have the locus, it has the separator here, and then it has the alleles. But it's saying it wants to have actually HLA dash in front of it. All right, and it's giving us this hint. HLA prefix add may be of interest to you. Look up its help file to see how to use it. All right, that's a great idea. So let's go down here to the console. We can hit question mark HLA. What are we doing here? Prefix add. Enter to get it there. Enter again to run that. We can see we got this HLA prefix add help file over here. All right, and the usage is pretty straightforward here. It just says the data and the prefix we want to add to it. And it's already telling us that it's hard-coded in there to have HLA-A put in. All right, so let's see. We're going to mutate. We're going to have a new mutate function down here. Mutate. And we can set it up pretty similarly here. We can say, all right, what we want to mutate is the HLA allele column, space, and equal sign, and then we're going to run HLA prefix add on it. I hit enter. It already has the parentheses up there. All right, and the prefix that we want to add, prefix equals HLA, like that. And at the end of this, we're going to need to put Control-Shift-M for another pipe, and let's see if that's going to work out the way we want. No, it didn't. All right, because, oh, this is great. I made a mistake in live data here. All right, so it's saying for this HLA prefix, we have to tell it what data to operate on, and we didn't put that in here. Right? We can see that for this HLA prefix add, the only parameter we put in was the prefix, but we got to give it data. All right, so the data we want it to operate on is the HLA.allele column. So now we're saying, all right, mutate HLA allele equals HLA prefix add, get the data from HLA.allele, and the prefix we want to add is there. Let's see if that works. Absolutely. All right, so that looks great. And so now we can see up here, we didn't have the HLA. Here we do have the HLA. And I'll just note that we can put anything we want in here, right? We could put HLA DRB1, for example. And if we did that, now it says HLA DRB1A asterisk 0201. That clearly doesn't make any sense, but we can add whatever we want there. And I will just point out one last time that if we remove that completely, Control-Shift-M, you can see that it works because HLA-A is kind of hard-coded in here as a default value to put in there. All right, so that line of code is even more complicated than everything we've done before, but hopefully it makes sense how we got there. All right, last prompt for this video here. All right, prompt 5. Take the code from above and add one more line. All right, complicated, getting more complicated all the time. Copy this down here. I'm going to paste it down here. This time, create a new column that removes the HLA prefix. See if you can find a function that does this and figure out how to set up the parameters so that the locus AB, DRB1, etc. is retained. All right, it's saying to put a new line of code in. So what I'm going to do here is just hit enter to get a new line of code. It wants us to create a new column. That's definitely the mutate function. It doesn't tell us what to call that function, so we can call it anything we want. Let's call it HLA.allele new. Why not? We can call it whatever we want. Space equal sign. All right, now we want something that removes the HLA prefix. All right, well, we have this HLA prefix add. I wonder if we start typing HLA prefix, oh, look at that. There just happens to be an HLA prefix remove function. I'm just going to go down on my keyboard to highlight that, hit enter, and now we have the HLA prefix remove. And it even pops up here and it shows us the parameters that we need to get this function to work. The first thing it needs is data, all right, and we can say, all right, we can certainly do that. HLA.allele is the data we want. Then we have to do comma, and then it's this thing about keep locus equals false. Sure, I don't know what's going to happen there. Keep locus, let's just type false in there because that's what it's set up to do. Let's see what happens. Oh, and of course, we forgot at the end here, Control-Shift-M to get that pipe put in there. If we run this again, now we can see we have this new column, HLA allele new, and we can see that we've removed all the prefix. Now the only problem here is you can see before We had A0201, for example, but now we've even removed the A, and especially since we have different loci here, if we removed that locus, it's not going to do us any good. And so now we can see why we have this keep locus function here. So why don't we try turning that to true and see what happens. Control-Shift-M will run that again. And look at that. Now we've gotten back to this HLA new. And if we go through here, we can see it's kept all of the loci there all the way to DRB5 down here. All right, great. So that was the end. That was the first one. That was the last one here. You can go down here. I have the answers for all of these different prompts down here. But hopefully you can see how you can use R and the Tidyverse and 3 of the functions in there, and some functions from the immunogenetr package that's specific for HLA data, how you can really start playing around and working with some cool HLA data. That's it for this video. Thank you everybody for watching, and hopefully I will be out with a new video very soon. All right, goodbye.